This is a tutorial for the use of the software program E-PipeAlator, specifically for geothermal heat pumps, but also for all sorts of other HVAC piping loops. The example today will be a 4-ton residential system with 4 bores, and we'll begin here. We'll look at this heat pump. It's rated at 12 GPM, and so we're going to try that. The way this is set up, we type the residential flow rate here as 12 GPM, and we have 4 circuits with 1 bore each. So when we put those numbers in there, they're automatically put into this column here. We'll start out with water at 60 degrees, the standard condition, and there's a lot of other things we could use, but we'll begin with water. We're going to try the heat pump here. We're going to, at its rated flow rate, is also 12, and at 60 degrees, 12 GPM, the head loss from the manufacturer's data is 10 foot of head, and it's a 1-inch connection on the heat pump. Okay, so you see the head loss is 10 because it's not corrected. Now let's go down here, and we'll first of all we're going to try to do this on the cheap, like some people do. It's a 4-ton unit, so we're going to try to put these headers in at 1.25 inch tubing. Okay, and it's a selection here typically is a DR11. You could put 13.5 for the horizontal sections if you wanted, but we're going to put in DR11, the standard. Now the length of the header is from the heat pump to where the U-tubes take off is 100 feet, so there is a supply and a return on that. So we're going to put 200 feet for the supply and return. Now we have a series of drop down boxes here with the fitting types. So the first thing, here's a blow up of how it looks right here. So we're coming in here, and this is a long sweep bend, so there's really no head loss across that. But we're going to try to see what the head loss is to this U-tube here. So the first thing we'll do is we'll come through a side branch of a T. So we'll cycle down, and it's a butt T and branch, and there's 2, one on supply, one on the return. And then we're going to go through a reducer here down to the U-tube pipe, so it's already in there. So it's a butt reducer, and of course there's 2 of them. Okay, and that will complete the header loss. We do have 2 up here where it goes into the heat pump, so we'll make that 4 reducers on the supply and return. We'll go back here and now begin to put the information in for the U-tube itself. And again, we're going to try to go on the cheap here and put the 3/4 inch pipe in there, DR11. You can see we'll come over here, and we have 200 feet down, 200 feet up, and then 10 feet and 20 feet over. So that would be 230 times 2 for the supply and return, so 460 feet. And then we go, this is again a sweep, so the only other fitting that we have there would be at the bottom. Yeah, we've already got that in there, so it's a unicoil, the U-tube at the bottom of the hole. So I don't see any other fittings, and we'll have one of those. Okay, so that'll get us the head loss from here to there. Okay, now the other thing is the head loss inside the U-tube where it comes in. So you'll see here, if you look real close, the fittings on here. We have these 2 ball valves here that isolate the pump, so we'll put in here, we'll call it ball valves down here at the fittings. Okay, and the flow again is 12 gallons a minute. And then we have this term C sub V, which is, we'll go here to the C sub V worksheet, and we can see we have 3/4, no, it's a 1-inch hose, a 1-inch pipe on the pump, and you can see that ball valve has a CV of 35. Now what that means is the flow rate in GPM through which a 1 psi drop occurs, and that's the terms people use for head loss. So we'll put 35 there, and we have 2 of them, one on the discharge and one on the suction, and it's 1 inch. Now we also have these 3-way valves, and the manufacturer gives us a CV for those. It's 23. Okay, so we have a 3-way valve, and it's also at 12 gallons a minute, and we put 23 for the CV. There's 2 of them, and the connection's 1 inch. Alright, then we go to these hoses. Again, we go to this CV worksheet, and we can see a 3-foot long 3/4 inch hose has a CV of 8.2. Go back to there, so hose, and then that's 12 gallons a minute. 8.2 is the CV, and there's 2 of them, and it's a 0.75 3/4 inch U-tube. Okay, so we got 36.7 foot of head. I think there's one more thing that we have to do. You look at where this goes in, there's an HDPE T right there. Okay, so we're going to have it's a 1 inch, I think. So we're going to put 12 right here, GPM, and we don't have any runs. All we have here is a T, but T run, so we have 2 of those. And I think one other thing I missed was the run of T here, so I'm going to put that in on the YouTube. I missed that earlier, so let's find that. Let's see, but T run, okay, and there's 2 of those, so it's not going to make much difference, but we got everything in. I'm pretty sure we do. Okay, now this is just with water, but let's say we're going to design it for the cooling mode, the heating mode, excuse me, where the temperature is lower and the viscosity is higher. So you can see it kicks it up just a little bit to 38.2. Okay, with that cooler, more viscous water. But what happens if we go up into climates where it's really cold and we want to use a little antifreeze, and it may get down to 30 degrees in the winter time? Okay, so now we're at 43 feet of head. Now what that's telling me is I'm going to need 2 pumps. 2 pumps, probably around 250 watts each, and that could knock a hole in your 4-ton efficiency, knock it down 8-10%. So let's try to look around, see if we can improve things, and we look for the big numbers. Okay, there's a fairly big number, the 12.5 on the YouTube, the 7.8 on the supply, and then there's another big one down here with these hoses. So probably the most inexpensive thing to do is, first of all, change the hoses. So we'll go back to C sub V, and we're going to go up to 1 inch, and we can see it's 16.4 CV. So we'll go back in here and change that to what did I say, 16.4, and it'll be a 1 inch. Okay, connection. So we dropped it down to 2.5. Alright, let's see what we can do about this here, this 7.5. Let's go to 1.5 inch header, and that knocked it down pretty good. Okay, and then here's the other thing, which is a little more critical, is let's try to see if we can't get this to a much better number by using a 1 inch U-tube. Okay, and you might get kind of worried that this is going into laminar flow, but see, there's a number right there, 2568. That's in transition, so we're good to go. So we're down to 23.7, which we could get with one pump, and I can assure you that pump's going to cost $500 or $600, and the cost of switching from the 1-inch to the 1-inch U-tubes and to the 1.5-inch headers is much less than $600. Okay, and we've improved the efficiency by about 10%. Okay, we could also try something, try another antifreeze. Let's try, I think a lot of people use ethanol, so we could use ethanol and get it down a little bit to 23.8, and we're in good shape. So it's very, very important to conduct this exercise if we're going to make these things efficient. That's our goal, make these things efficient, and the bigger the pumps, the less efficient they are, and so we can improve that by judicious use of this program to reduce pump size. So I encourage you to do your analysis, and I hope this helps you out.